Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics.
The Carolina Bays, 90 Years of Progress. In 1930, an aerial survey near Myrtle Beach, South Carolina, revealed large numbers of elliptical features oriented in a southeast direction. The origin of the Carolina Bays has been one of the most contentious topics in geology, comparable to the great arguments about the Missoula floods or continental drift, which is now known as plate tectonics. The debate of the Carolina Bays centers on whether the bays were created by the action of wind and water, called the terrestrial hypothesis, or whether the bays were created as a result of an extraterrestrial impact, known as the celestial hypothesis. The Algonquian Native Americans knew the Carolina Bays as swampy areas called pocosins. The regular shapes and the orientation of the features in this photographic mosaic caught the attention of scientists. In 1933, Melton and Shriver considered that the Carolina Bays were meteorite scars. Although the orientation of the bays and their shapes were suggestive of a meteorite shower, no pieces of meteorites were found in or around the bays. In 1942, Douglas Johnson wrote a book proposing that the Carolina Bays originated by a complex mechanism involving artesian springs and that the sandy rims were created by the action of water currents and wind-blown sand. Johnson dismissed the meteorite impact hypothesis because, according to him, it failed to provide a satisfactory explanation of the facts observed, such as the highly irregular outline of many bays and the undisturbed condition of coastal plain beds adjacent to the bays. In 1952, William Prouty pointed out deficiencies in Johnson's complex hypothesis and suggested that overlapping Carolina Bays could be best explained by tandem impacts. He used a high-powered rifle for experiments showing that the air blast from a bullet in an oblique trajectory blew away surface dust that left an elliptical depression. The tug-of-war between the proponents of celestial and terrestrial hypotheses continued. In 1954, C. Wyeth Cook proposed that eddies in water currents shaped the Carolina Bays into ellipses. Just 2 years later, this hypothesis was refuted by Melton, who was a co-author of the 1933 meteorite shower paper. In 1975, Ayton and Parkhurst suggested that the extraterrestrial origin of the Carolina Bays should be reconsidered. They proposed that fragments of a comet approaching from the northwest could have created the bays in explosions like the one in Tunguska in 1908. In 1977, Raymond Kaczorowski wrote a thesis comparing the Carolina Bays to oriented lakes. This thesis has been cited often by proponents of the terrestrial wind and water hypothesis, although the thesis was never published in a peer-reviewed journal. Kaczorowski conducted an experiment where he carved a circular indentation on a sand tray. He then filled the circular cavity with water and set a fan to blow over the pool. He changed the fan to blow in opposite directions, as indicated by the arrows, every 15 minutes for 4 hours, although the reversal of wind direction is not something that regularly happens in nature. His experiment produced a football-shaped pool from which he concluded that wind and water mechanisms such as these could have formed the Carolina Bays. In 2006, Richard Firestone and Alan West published a book entitled The Cycle of Cosmic Catastrophes: How a Stone Age Comet Changed the Course of World Culture. This book was the first version of what was later called the Younger Dryas Impact Hypothesis. Chapter 17 of the book is entitled The Carolina Bay Craters and points out that no new bays are being formed anywhere in the world today by common terrestrial processes, and that the bays could have an impact origin as proposed by previous researchers such as Prouty. The Cycle of Cosmic Catastrophes book was followed in 2007 by a peer-reviewed publication by Firestone and 25 co-authors in the prestigious journal Proceedings of the National Academy of Sciences. The paper proposed that one or more large, low-density extraterrestrial objects exploded over North America 12,900 years ago and contributed to the megafaunal extinctions and the Younger Dryas cooling. The evidence for the impact consisted of magnetic microspherules, nanodiamonds, and other proxies that were attributed to the airburst of an extraterrestrial object. The Carolina Bays, that had been so prominently discussed as craters in the Cosmic Catastrophes book, were only mentioned as locations from where soil samples were collected. When the 2007 paper was written, the mechanism by which the Carolina Bays formed could not be explained, and therefore the bays could not be included in the peer-reviewed publication. George Howard, who was a co-author with Firestone, said,
In 2007, the Carolina Bays became the kooky caboose of the theory.
The reason for the omission of the Carolina Bays in Firestone's 2007 paper became clear with the publication of America Before by Graham Hancock. In a letter addressed to Hancock, Malcolm Lecompte explained, "You may not be aware of the time and energy spent to largely neutralize the distracting effects and hostility created by the early Carolina Bay-related assertions made in the non-peer-reviewed book Cycle of Cosmic Catastrophes. The association of Bay impact genesis with the Younger Dryas impact hypothesis created an early perception in some scientific communities that the Younger Dryas boundary impact research was both unprofessional and bordering on pseudoscientific. Those original, naive Bay genesis claims still haunt the research and contribute to hobbling its acceptance as a legitimate research activity for a new generation of scientists." In spite of the objections, Firestone persisted trying to link the Carolina Bays to the Younger Dryas impact hypothesis. In 2009, he published a paper in the Journal of Cosmology showing the radial orientation of the Carolina Bays and Nebraska rainwater basins. Firestone wrote that a high-temperature shockwave from a meteorite airburst near the Great Lakes raced across the continent, creating the Carolina Bays as it passed and covered them with impact debris. Firestone said that the winds from the shockwave were consistent with the orientation of the bays and the theory that they were Aeolian in origin, as Kaczorowski had proposed. LiDAR images produced by a laser ranging technology became widely available in the first decade of the 21st century. These images revealed that the Atlantic coastal plain was completely covered with Carolina Bays. In 2010, Davies and Gilbride calculated the convergence point of the Carolina Bays and the Nebraska rainwater basins at Saginaw Bay based on their axial orientations. The calculation required using great circle trajectories and taking into consideration the Coriolis effect caused by the rotation of the Earth. 7 impact experts published a paper in 2011 entitled The Younger Dryas Impact Hypothesis, a Requiem. This paper discredited the evidence in the 2007 paper by Firestone by saying that the physical evidence interpreted as signatures of an impact event consists of evidence that has been largely rejected by the scientific community and is no longer in widespread discussion, including the impact origin of the Carolina Bays. The authors had a dire warning. The Younger Dryas impact hypothesis provides a cautionary tale for researchers, the scientific community, the press, and the broader public. This paper was very influential in stopping funding and research on the Carolina Bays and the impact hypothesis. The experts wanted proof of the kind that had been established during the study of Meteor Crater in Arizona in the 1960s. Such evidence consisted of a crater with raised rims and overturned flaps, meteorite fragments, siderophile elements, shattered cones, and crystals with planar deformation features created by the high pressures of an extraterrestrial impact. In 2013, an attempt to put the final nail in the coffin of the Younger Dryas impact hypothesis actually produced supporting evidence. A large platinum anomaly was found in the Greenland ice core at the Younger Dryas boundary. Platinum is a rare element on the Earth's surface, but it is associated with iron meteorites. The authors concluded that the platinum spike could be due to the impact of an iridium-poor iron meteorite that was unlikely to result in an airburst. In other words, the Earth was hit by an iron meteorite 12,900 years ago, and such meteorites usually crash into the ground instead of just exploding in an airburst. This paper gave new life to the Younger Dryas impact hypothesis and focused attention on platinum rather than iridium as the main siderophile element associated with the impact. In 2014, I published a book entitled Killer Comet: What the Carolina Bays Tell Us. By this time, I had concluded that the elliptical geomorphology of the Carolina Bays was proof of their origin as inclined conical cavities, and I had calculated that the secondary impacts of glacier ice ejected by an extraterrestrial impact on the Laurentide ice sheet had sufficient energy to liquefy saturated soil, which meant that the glacier ice impacts could create inclined conical cavities. This was the first publication describing the glacier ice impact hypothesis and the emplacement of the Carolina Bays as the cause of the North American megafaunal extinction. LiDAR, a laser ranging technology, enhances the visualization of the surface of the Earth, and it allows us to look at the ground without interference from vegetation. Features that are invisible in aerial or satellite images stand out when viewed with LiDAR. Geologists have tried to correlate the Carolina Bays with other structures found on the Earth ever since the aerial views of the bays gained attention. The Carolina Bays differ from other geological features because of their remarkably smooth elliptical margins, their radial orientation toward the Great Lakes, their raised sandy rims, and their occurrence only on unconsolidated soil close to the water table. Salt lakes in Australia seem to be aligned and have an oval shape. These lakes form when floodplains dry up and leave isolated lakes. These lakes do not have the consistent shape or the raised rims characteristic of the Carolina Bays. Some geologists have proposed that the Carolina Bays are like thermokarst lakes that form when subsurface ice melts, creating a sinkhole that fills with water. But unlike the Carolina Bays, these lakes do not have the regular elliptical shapes and raised rims of the Carolina Bays. This slide compares LiDAR images of the Carolina Bays and Alaskan lakes. The Carolina Bays have smooth regular geometry and raised rims, whereas the Alaskan lakes have rough edges, irregular proportions, and they don't have raised rims. The difference between the Alaskan lakes and the Carolina Bays is appreciated better by trying to fit ellipses with width-to-length ratios corresponding to the features. The ellipses fit the Carolina Bays precisely, whereas the Alaskan lakes have margins inside and outside the elliptical image. LiDAR has changed the way in which we look at the land. In this satellite image, there is a faint image of a bay in the middle of a plowed field. The bay would be completely hidden if the field had a crop. Such faint images are called ghost bays. A LiDAR image of the same area reveals the ghost bay and several larger bays that were not visible in the satellite image. In 2001, elliptical features similar to the Carolina Bays were reported in Nebraska. The bays in Nebraska are called rainwater basins, and they are oriented toward the Great Lakes like the Carolina Bays. However, the major axis of the Carolina Bays is oriented toward the northwest, but the major axis of the Nebraska rainwater basins is oriented toward the northeast. The early literature describes the Carolina Bays as either oval or elliptical. An oval is an egg-shaped figure without a mathematical curvature, but an ellipse is a curved path that follows a precise mathematical formula. It is possible to verify that the Carolina Bays are elliptical by measuring the width and length of a bay and overlaying the bay with an ellipse that has the same width-to-length ratio. This is easily accomplished using an image editor like Photoshop or GIMP. Well-preserved Carolina Bays and Nebraska rainwater basins have mathematically elliptical geometry. This is a very important characteristic that provides insight into the mechanism of bay formation because ellipses are conic sections. Geometrical shapes provide evidence of the forces of nature. Spheres are formed by matter coalescing under the influence of gravity or surface tension. Circles are produced when an object strikes water, sending a shock wave along its surface. Cones are formed by the passage of a projectile through a viscous medium. These cones are sometimes called penetration funnels. Ellipses are conic sections that describe the orbits of planets and the geometry of the Carolina Bays. The Nebraska rainwater basins and the Carolina Bays are elliptical structures separated by 1,800 kilometers. Their major axes are oriented toward the Great Lakes. This is another significant clue about their origin. Zanner and Kuzila wrote in 2001 that any explanation for the existence of the Carolina Bays should also help to explain Nebraska's rainwater basins. Some bays are enormous and still maintain their elliptical geometry. This bay near Fayetteville in North Carolina has a width of 2.1 kilometers and a length of 4.1 kilometers. The mall in Washington, D.C., from the Lincoln Memorial to the Capitol building, could fit inside this bay. The elliptical geometry of the Carolina Bays and Nebraska rainwater basins is easily verified with graphic editing software. The fact that well-preserved Carolina Bays are conic sections with width-to-length ratios of approximately 0.58 led to the hypothesis that explains these characteristics. In 2015, the book entitled Solving the Mystery of the Carolina Bays defined the Carolina Bays as shallow elliptical depressions with raised rims on unconsolidated ground whose major axis is oriented toward the Great Lakes region. The prototypical Carolina Bays are elliptical in the mathematical sense, and they have an average width-to-length ratio of approximately 0.58. Carolina Bays only occur within a radius of 1,500 kilometers from the Great Lakes. The Carolina Bays have been examined in many ways by many people since their discovery. Biologists have looked at the bays as ecological habitats that sustain a variety of plants and animals, while geologists have taken samples to examine the stratigraphy, chemical composition, and age. In 2014, I spent the 4th of July in Myrtle Beach, and I took a few side trips to look at the Carolina Bays. I collected soil samples doing research for my books. In 2017, George Howard organized a meeting in Wilmington, North Carolina. We visited Jones Lake State Park, which is the site of a Carolina Bay with a length of 2.3 kilometers. This image shows Graham Hancock, George Howard, and Michael Davies. Graham wanted a first-hand look at the Carolina Bays to gather material for his book, America Before. Santa Faia and Randall Carlson participated in the meeting and exploration. Santa Faia took this picture of me and Graham at Jones Lake State Park. Michael Davies provided maps for the exploration of 3 Carolina Bays that were easily accessible by roads. We pulled over to the side of the roads at several places to set up the drones. Brad Young flew a drone to get aerial views of the bays and the terrain. Santa Faia had another drone. The morning had been cloudy and rainy, but the weather was sunny when we were exploring the bays. In 2019, George Howard conducted an excavation of Arabia Bay in North Carolina to take some samples for analysis. This was the first time that the apex of a Carolina Bay had been investigated for impact evidence. One of the reasons for digging at the apex was to look for glacial till brought within the chunk of glacier ice that made the bay. Arabia Bay is on a farm owned by Mr. Harris, and the field was being restored back to a wetland by Restoration Systems LLC. The samples taken during the excavation are being processed by Chris Cottrell, and they will be sent for laboratory analysis. Confirming that the Carolina Bays and the Nebraska rainwater basins are mathematical ellipses and that their major axes converge by the Great Lakes made it possible to formulate the glacier ice impact hypothesis. The glacier ice impact hypothesis, published in the journal Geomorphology in 2017, describes 4 mechanisms by which the Carolina Bays may have formed. First, a meteorite impact on the Laurentide ice sheet ejected ice boulders in ballistic trajectories. The secondary impacts by the ice boulders liquefied on consolidated ground close to the water table. Oblique impacts of ice boulders on liquefied ground created inclined conical cavities, and viscous relaxation reduced the depth of the conical cavities to produce shallow elliptical bays. Pictures of experimental impacts contributed to the acceptance of the hypothesis for publication in the peer-reviewed journal. Confirming that the Carolina Bays are conic sections made it possible to use the mathematical empowerment from the laws of physics. The ellipticity of the Carolina Bays is used to determine the angle of impact, which is also the approximate launch angle of the ice chunks from their point of origin. Ballistic equations use the distance of the bays from their convergence point to calculate launch speeds, trajectory heights, and duration of flight. Yield laws correlating energy to crater size are used to calculate the mass and size of the secondary ice projectiles. Using the law of conservation of energy, we can add the energy for creating all the bays to estimate the energy and size of the extraterrestrial impact. The mathematical model makes it possible to provide a minute-by-minute account of the Younger Dryas impact event. The calculations start by obtaining the width-to-length ratio of a Carolina Bay to find the angle of impact. The distance from the convergence point to a particular bay is measured with Google Earth. The distance and the angle of impact are used to calculate the launch speed. Once the launch speed is known, the time of flight and the maximum height of the trajectory can be calculated. The size of the bay, the launch speed, the impact angle, and the type of projectile and target are used to calculate the energy of the impact and the size of the projectile, using power law scaling equations published by Professor J. Melosh and Ross Baer. A Carolina Bay with a diameter of 1 kilometer requires an ice projectile with a diameter of 180 meters and energy of 3 megatons of TNT. The impact calculations indicate that a bay with a diameter of 200 meters requires 13 kilotons of energy, equivalent to a 6.0 magnitude earthquake. A Carolina Bay with a diameter of 1 kilometer requires an ice projectile as large as Yankee Stadium with 3 megatons of energy, equivalent to a 7.54 magnitude earthquake. Seismic vibrations of magnitude 6.0 or higher are strong enough to liquefy saturated ground, and impacts on liquefied ground produce conical cavities. Adding up all the energy to produce the Carolina Bays, we can get a rough estimate of the extraterrestrial impact on the Laurentide ice sheet of approximately 6.35 times 10 to the 21st power joules. This corresponds to the kinetic energy of an asteroid with a diameter of 3 kilometers or a comet with a diameter of 2 kilometers. The volume of the ejected ice projectiles is approximately 1.5 times 10 to the 12th cubic meters of ice, which corresponds to a 44-kilometer crater on the Laurentide ice sheet. The ballistic equations and knowledge about the propagation of seismic waves makes it possible to deduce the details of the Younger Dryas impact event. Ice was ejected from the Laurentide ice sheet in ballistic trajectories for 30 seconds during the excavation phase of the meteorite impact. The shock waves of the impact reached the east coast 4 minutes later. The ejected ice boulders started falling on the east coast from 6 to 9 minutes after the extraterrestrial impact. The ballistic sedimentation of the ice boulders was complete by about 10 minutes after the impact. Plants and animals within 1,500 kilometers of the epicenter were destroyed by the ice impacts. The extinction was localized from the Rocky Mountains to the Atlantic coast, but it was aggravated by the destruction of habitat and the onset of a global winter that made life hard for any survivors outside the kill zone. Beyond the 1,500-kilometer radius where the Carolina Bays and Nebraska rainwater basins are found, there are many Younger Dryas boundary sites with black mats. These black mats formed from paleosols, diatomites, or algae that developed in the wet conditions that followed the onset of the Younger Dryas cooling event. The scientific method requires a hypothesis to be testable, and experiments are used to test the hypothesis. Experiments have played a great part in figuring out what happened at the onset of the Younger Dryas. Professor Peter Schultz has conducted impact experiments showing that high-speed projectiles impacting ice sheets eject pieces of ice in ballistic trajectories from the impact point, and that a layer of ice prevents the formation of a typical crater on the surface below. The impacts produce ice pieces of various sizes. This explains the different sizes of the Carolina Bays. Some experts have claimed that an impact on ice would just melt the ice, but experiments show otherwise. Ice is a bad conductor of heat, and the ice fragments are ejected before enough energy can be transferred to melt the ice. For my first proof-of-concept experiment, I threw tiny pebbles into a container with pottery clay. This experiment demonstrated that inclined conical cavities with raised rims could be produced by oblique impacts, and that viscous relaxation reduced the depth of the cavities to produce shallow elliptical features. My subsequent experiments used a mixture of sand and pottery clay with enough water to have the consistency of bricklayer's mortar. A thin layer of colored sand was used to enhance visualization. I wanted my experiments to show how features like overlapping Carolina Bays could be created by adjacent impacts. I also wanted to verify that oblique impacts of ice projectiles could produce elliptical bays with raised rims. The Carolina Bays do not have distorted stratigraphy, so I also tried an impact on a target with a red layer to demonstrate that viscous relaxation can restore the stratigraphy. My experiments showed that the penetration of the projectile on viscous ground creates an overturned flap that becomes a raised rim. I expected the rim to have inverted stratigraphy, and I found out that in 2012, Ted Bunch et al. Had reported inverted stratigraphy in a Carolina Bay rim. The mechanism of formation of some distorted Carolina Bays was difficult to figure out until the characteristics of the terrain were taken into consideration. Geometric analysis of the distorted bays showed that the downhill portion of the bays was elliptical, but that the uphill portion of the bay was distorted. This could be explained if during viscous relaxation the liquefied terrain flowed into the conical cavity like a mudslide. I tried to recreate these terrain conditions by tilting the experimental container during viscous relaxation. The diagram on the lower left shows that a conical cavity on inclined terrain has a steeper inclination on the uphill side that allows more mud flow, thereby creating the distortion. This is exactly what was observed in the experiment. Some terrains demonstrate a very dynamic environment during the emplacement of the bays. From the law of superposition, Kelly Bay was emplaced first. Then, impacts in the adjacent river scoured and transported sediment, creating splash chevrons on top of the bay. And finally, small ice projectiles with high trajectories and long flight times produce small bays on the splash chevrons. If all the Carolina Bays were created contemporaneously, they should all have the same date. Many scientists oppose the impact origin of the Carolina Bays because a wide range of dates is associated with the terrain where the bays are found. Radiocarbon dating is based on the decay of carbon-14 to nitrogen-14, which has a half-life of 5,730 years. Organic materials containing carbon, such as wood or collagen in bones, can be dated by this method. Unfortunately, even though radiocarbon dating can be very precise, many things can go wrong due to carbon turnover from deep oceans, release of carbon-14 from biomass burning, and vertical transport of organic material in sedimentary sequences. The 2009 paper by Firestone had examples where several Carolina bays had dates in the future, presumably from an unknown source of carbon-14 enrichment. Optically stimulated luminescence, or OSL, was used by Brooks, Taylor, and Ivester to date Big Bay in South Carolina. This bay and the sand rims had dates ranging from 2.2 to 74.3 thousand years ago, leading to the logical conclusion that the bay formed episodically over many thousands of years. However, notice that Big Bay has the same characteristics of emplacement as Kelly Bay. An initial impact created Big Bay. Then, other impacts on the river scoured sediment and created the splash chevrons that cover the portion of Big Bay. Finally, a small ice projectile with a high trajectory and long flight time produced a small bay on top of the chevron. The splash chevron is described by Brooks, Taylor, and Ivester as an Aeolian sandsheet, but the texture seems too rough to be a sand dune. Optically stimulated luminescence, or OSL, measures the time that quartz or feldspar crystals have been buried while being exposed to the natural radiation in the ground. Sunlight resets the OSL signal. OSL dating is applicable to soils deposited by gradualistic sedimentary processes. The samples for OSL dating must be kept in complete darkness before the test. A lot of information about the location of the sample must be provided for accurate dating. Depth of burial below the landform surface is needed to calculate cosmic dose rate. It is best if the sample is more than 1 meter below the landform top to minimize cosmogenic dose errors. The latitude, longitude, and elevation of the sample must also be recorded for calculation of the cosmic dose rate. Impact structures like the Carolina bays cannot be tested by optically stimulated luminescence because they were created by plastic deformations that became shallow elliptical structures by viscous relaxation. This experiment shows that only the new surface of the conical cavity is exposed to light at the time of formation. The reduction in the depth of the cavity due to viscous relaxation does not expose any new surface to light. So any test of the soil 1 meter below the surface is going to determine the date of the terrain, but not the date of bay formation. The wide range of dates obtained from the different terrains where the bays are found has posed a great obstacle to the acceptance of the impact origin of the Carolina bays. It will take some time to convince geologists that impact structures like the Carolina bays cannot be tested in the same way as sedimentary depositions. The Younger Dryas global cooling event and the extinction of the megafauna 12,900 years ago are well accepted in the scientific community, but the idea that these events were caused by an extraterrestrial impact is vigorously contested. The extinction of the megafauna is often attributed to climate change and human overhunting. An extraterrestrial impact on the Laurentide ice sheet would have ejected ice boulders to produce the Carolina bays, and the water ejected above the atmosphere would have produced a fog of ice crystals in low Earth orbit that blocked the light of the sun, increasing the albedo of the Earth and triggering a global winter. Fires caused by the passage of the bolide would fill the atmosphere with smoke. The smoke would be near ground level, where it would be washed out by rain and snow in a few years, but the ice crystals would stay in orbit, perhaps for hundreds of years, until they sublimated into water vapor. The Carolina bays are evidence of the saturation bombardment of glacier ice boulders ejected from the Laurentide ice sheet by the extraterrestrial impact. The Carolina bays are the most notable geological features of the Atlantic seaboard. This image, 25 kilometers southwest of Fayetteville, North Carolina, shows that there was nowhere to hide from the impacts of the ice boulders that made the bays. Applying the power law equations published by Professor J. Melosh and Ross Baer, we can see that the Carolina bays were formed by impacts with energies of many megatons. Could the mastodons and Clovis people have survived? Obviously not. This is why the emplacement of the Carolina bays must be associated with a megafaunal extinction event, thereby establishing the date of emplacement of the bays. Glacier ice boulders impacting solid ground could not liquefy the ground to form Carolina bays, but they fragmented into high-energy ice shards that were lethal to the megafauna. The Orleton Farms mastodon may have been a victim of such a barrage. One of the ribs lay beneath one of the tusks, while another was thrust through an aperture in the pelvis. A shoulder blade rested to the right of the skull, and one of the large neck vertebrae was found about 10 feet from the skull near a portion of the pelvis. Yet, the bones of one of the feet remained intact and in place, very possibly in the spot where the animal last stepped. The study of a site in Chile reported the extinction of megafauna in South America also at the Younger Dryas boundary. This provides support for the hypothesis that the Earth was hit by multiple comet fragments approximately 12,900 years ago. 3 sites can be considered as potential impact locations from comet fragments at the onset of the Younger Dryas. The Greenland crater under the Hiawatha Glacier, whose date has not been firmly determined. The Saginaw Bay area, which does not have a typical extraterrestrial impact crater, but which is the convergence point of the Carolina Bays and the Nebraska rainwater basins, and the Iturralde crater in Bolivia, which is thought to be the result of an airburst like Tunguska and has an age estimate ranging between 11,000 and 30,000 years ago. The probability of an extinction-level extraterrestrial impact is considered low. This assessment of low risk and the doubts raised by the Requiem paper about the Younger Dryas impact hypothesis have discouraged the study of extraterrestrial impacts. There are potential impact craters, such as the feature in Florida that is immediately outside of Miami Harbor in shallow water. The feature remains unexplored 8 years after its discovery. Sometimes, research in unrelated fields comes together to provide support for the Younger Dryas impact hypothesis or for the effect of the cataclysm on the human survivors. A broad, multidisciplinary perspective is necessary to connect the dots. A study of the draining of glacial Lake Agassiz in Canada found that the main eastern channel to the Great Lakes in the North Atlantic opened at 13 to 12.7 thousand years ago through the lower Great Lakes to the Gulf of St. Lawrence and the North Atlantic. Although the paper was only concerned with the draining of Lake Agassiz, the time at which the eastern outlet opened and the location of the opening are consistent with the idea that an extraterrestrial impact on the Laurentide ice sheet in the Michigan Peninsula could have fractured the ice sheet and facilitated the flow of water eastward through the St. Lawrence River. This is just speculation, but it fits the broader narrative. Another study not related to the Younger Dryas megafaunal extinction shows a strong genetic bottleneck in human males starting at about that time. The authors attribute this decline to cultural changes affecting variants of reproductive success among males, but since the decline in Y chromosome diversity starts simultaneously at the time of the Younger Dryas in all regions of the world, it is tempting to conclude that the decrease in global temperature caused the bottleneck, particularly because cold ambient temperature influences the characteristics of populations by affecting selection in utero. Low temperatures may call males in utero, according to a paper published by Ralph Catalano. The decrease in the Y chromosome diversity starts gradually at the onset of the Younger Dryas 12,900 years ago. Then it drops suddenly and it continues to decrease well beyond the 1,300-year duration of the cold event. The increase in the Y chromosome diversity is just as abrupt as the end of the Younger Dryas. It is worth noting that the Near East and Caucasus region in orange recovers the fastest. This region corresponds to Mesopotamia, which is the cradle of modern civilization. An extraterrestrial impact on the Laurentide ice sheet, with the subsequent ballistic sedimentation of glacier ice pieces ejected by the impact, provides the best explanation for the radial orientation and the elliptical geometry of the Nebraska rainwater basins and the Carolina Bays. The orientations are telling us something, and we should not ignore it. The major axis of the Carolina Bays and Nebraska rainwater basins converge at Saginaw Bay in Michigan, according to Davies and Gilbride. There is no typical crater at this location, but if a comet fragment hit an ice sheet at this location, the ice sheet would have prevented the formation of a typical crater, and the subsequent melting of the ice would have washed away most of the evidence. Some clues about the extraterrestrial impact, such as increased platinum, may still exist in the layers of sediment of the Great Lakes. This should be an area of intensive research. I don't want to leave the impression that there are no objections to the glacier ice impact hypothesis. Some scientists have said that Saginaw Bay had no ice 12,900 years ago because by that time the Laurentide ice sheet had receded. Thus, an impact at that location could not have ejected ice boulders to form features like the Carolina Bays. However, this argument does not explain why the bays converged at Saginaw Bay. Also, we really don't know how much geological disturbance would have been caused by an extraterrestrial impact on the ice sheet and the flooding that followed. The impact of a 2-kilometer meteorite on the ice sheet could have obliterated the moraines and other geological features used by glaciologists to determine glacier coverage, making it appear like there was no ice at that location at the onset of the Younger Dryas. The confirmation that the Carolina bays are geometrical ellipses provides support for the hypothesis that the bays originated as inclined conical cavities, and this can be demonstrated experimentally. The overturned flaps from the penetration funnels become the raised rims of the bays. Geologists will eventually have to accept that the Carolina bays and the Nebraska rainwater basins are impact structures. Now that the mechanism for the formation of the bays has been published in a peer-reviewed journal, perhaps the Carolina bays will go from being the cookie caboose of the theory to become an integral part of the Younger Dryas impact hypothesis as envisioned by Firestone in his 2009 paper.
Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.